This is the video for Math 0530 Statistical Principles, Day 2, Mini Lecture, Part C. In Part C, we're solving applications of exponents, fractions, and mixed numbers. Write the numeric expression which should be evaluated to solve each of the following problems. Now, these directions do not tell us to solve the problem, right? We're just going to write a numeric expression. Number 1. On average, a human adult's body is about 13/20th parts water, the fraction 13 over 20, 13/20th parts water. What portion of an adult human's body is not water? So we need to think of what operation would apply here. We want to think of the whole human body. So what number represents one whole? The number 1, right? So we want to take one whole adult human body, and we know how much is water, this fraction here, and we want to know what is not, what part of the body is not water. So if we take the whole body, the number that represents the whole, 1, and we subtract off the part that is made up of water, then that's the expression that we would evaluate if we wanted to solve that problem and answer that question about what portion is not water. In number 2, a container of ice cream holds 1 3/4 quarts. How many ice cream would 8 containers hold? Sometimes it's helpful just to visualize this. So we have a carton of ice cream, and it holds 1 3/4 quarts. So let's put another carton next to that. So now we have a 1 3/4, we have another 1 3/4. So adding those together would tell us how much ice cream we would have in 2, right? And if we put another one beside those 2, we would have 3 containers, 1 3/4 plus 1 3/4 plus 1 3/4. And we would do this 8 times. And we could write it that way, where we write 1 3/4 with using addition and write it 8 times. But what's the more simplified way to write that expression? Well, you're hearing that word times, maybe you're thinking multiplication, because if we just said we've got 8 cartons and each one of those holds 1 3/4 quarts of ice cream, this would tell us the total amount of ice cream we would have if we had 8 containers. How many 4/5 foot planks can be cut from a board which is 12 feet long? This is another one that's really good to visualize. So you've got a board. Let's see if we can just sketch a little board here, and let's pretend like this board that I've drawn is 12 feet long. So now what we want to do is cut it up into pieces that are each, 4/5 of a foot. So this isn't going to be at all relatively correct, but I just want you to see that if I cut once and this one's 4/5 of a foot, and this one, and this one, and this one, and so on, what operation would give me the answer to that? To how many 4-foot planks can I cut? How many 4/5 foot planks can be cut from a board that's 12 feet long? Well, what I've done is I started with my 12-foot board, right? Start with the board, and then what did I start doing? I divided it by sizes that were each 4/5 of a foot. Each one of these was 4/5 of a foot. I just visually interpreted that now into an expression, and that would tell me how many of these planks I can cut from that board. Number 4, Tiffany is walking a path that's 8 2/3 miles long. She has already walked 5 1/4 miles. So how many miles does she have left to walk? Okay, so this is a total, we've got the total, 8 2/3 is her total journey, and she's already completed 5 1/4 miles, so how much is left? You thinking of the operation? Take the total and subtract what's already been accomplished, right? That's done. And that will give us the remainder, how much she has left. A plot of land, which is 8 2/5 acres, is to be divided equally among 3 heirs. How many acres should each heir receive? Okay, so think about this one visually. You've got this nice big plot of land, and the whole thing is 8 2/5 acres. And these 3 people come out there and they want their equal part. Well, what's one easy way to divide that up would be just to run a property line there equally so that each one gets what fraction of that? 1/3, right? So how would we write this as an expression? We would say we have this big piece of property that's 8 2/5 acres, and we want to divide it up into 3 parts, right? Okay, if 3 cows yield 4 1/3, 5 3/8, and 6 1/4 gallons of milk one day, what's the total milk production of the 3 cows for that day? Well, this one's pretty easy, right? The total of the 3 cows, we're going to add these, right? We're going to add the first cow's production plus the second cow's production plus the third cow's production. And that would give us the total for the day. Number 7, Keisha has a monthly budget of $1,540 and must allocate 2/7 of it for groceries. How much is she allocating for her groceries every month? So 2/7 of it being what? It is the total she has, right? This word of, 2/7 of, implies, or we think of that as multiplication. We know that the answer to this is going to be some number less than $1,540, right? Because 2 over 7, 2/7, is a proper fraction, and it's not even equal to 1, not anywhere close to the total amount. So here's how we would get that answer. If we take 2/7 of multiplied by 1,540, that will tell us how much of that $1,540 she must allocate for her groceries. Randy's car averages 8 1/2 miles per gallon. Last week, he used 26 gallons of gas. How many miles did he travel? So what operation do you think is going on here? Well, think about it. When he puts gas in his car, he puts in 1 gallon of gas. Let's think of this as just a gallon of gas right here. That's going to get him 28 1/2 miles down the road, right? But he didn't just put 1. He kept putting gas in and putting gas in, right? And each time he's given himself another 28 1/2 miles each gallon. Here's a gallon. This is 1 gallon. This is 1 gallon. Here's another gallon. So he gets to go another 28 1/2 miles. How many gallons did he use? Did he end up putting in his tank total? 26 of those, right? So we could add up all our boxes after we've drawn those, and that would be 26, right? And each time we're getting 28 1/2, 28 1/2. We could add all that up, but what's the simpler way to get this result? We say 26 times 28 1/2, right? Because each one of these allowed him to go 28 1/2 miles, right? and he used 26 gallons. Sometimes drawing a little picture can help you understand a problem. Don't ever hesitate to do that if that helps you. Okay, we're ready for our checklist. With a partner, complete the TI 8384 calculator activity, which was attached to the Day 2 handout. Now, if you're doing this outside of class, you may do the calculator activity on your own. But be sure to do every step and check your answers. They're provided on the handout. Your Math 0530 instructor must check your calculator activity. So if you're doing this outside of class, you need to show it to your Math 0530 instructor because you want to get credit for this exercise. And they'll have to enter that in MyLabs Plus for you. That's the second part of the checklist. Then you're ready to do Labs 2A and 2B. And if you finish all of that and you have some 1530 homework, that's what you need to be working on.